Okay. So I want to start by sharing the course outline, taking you through the course outline, what we are supposed to cover in this course. And as you have seen, the university courses are coded, and it is given a unique code. So this particular one is coded AIU 113. When you see a course coded AIU, it means AMREF International University. So it's a university common course. And I know you'll be taking other courses, also other common courses. So this is one of the common courses you'll be taking, and it is titled, the course title is Information Communication Technology, basically ICT. It is a 3-credit-hour course. What that means is that we are supposed to be having or taking 3 hours per week to study this course. And I think I've explained that it will be on Mondays from 5:30 to 8:30. Those are 3 hours. What is the purpose of the course? The purpose of this course is it is to prepare you as a student with the skills for the application of information, communication, and technology during your training, professional practice, research, and learning. You realize that we have various technologies, ICTs, and now we are going to learn how to apply those ICTs in our training. Like you'll be required to do assignments. Those assignments, you are supposed to use an ICT tool. How do you use it? Some of you are working. That is, you're in a professional practice. Even those who are not working, they are preparing to work. Or we are preparing you to work or to practice, professionally practice. So as you practice, you need to apply ICT. So we are going to impart you with those skills. And then research and learning, that you are supposed to carry out research. Research can be for personal development. It can be for academic work. So as you carry out research and as you learn, you are supposed to be using ICT. So we need to prepare you with those skills to apply those technologies in those areas. The expected learning outcomes, by the end of this course, you as a student is supposed to be able to outline basic computer skills. What this one would be, actually we'll have like a discussion or a debate. I can call it a discussion forum, whereby we will share, included, how we are using computer skills in learning and in performing our professional functions, so that we learn from each other what areas we can apply ICTs. We are going to, at the end of the course, we are supposed to describe various application softwares for research and practice. What softwares do you use for research and for your professional practice? Thirdly is, by the end of the course, you should be able to appraise the role of ICT in the professional practice. What is the role? What is the impact of ICT in your practice? And even we think forward, what is the future of ICT in our various professional practice? Then lastly, we'll be able to look at the challenges in the adoption and the use of ICTs. So what are the challenges which we are facing as we use ICTs, as we adopt ICTs? And whenever we look at challenges, it's always good to look at what are the possible solutions to these challenges, so that we don't look at the challenges and we are not answering or looking at solving those challenges. So those are the 4 outcomes you are supposed to achieve by the end of the course. Looking at the course content, and this is what you are supposed to cover, or what we call the topics and the subtopics you are going to cover in the course of study, so that you achieve the 4 learning outcomes. You start with the introduction to ICT, and in the introduction to ICT, you look at the history of the personal computer, of the computers. We look at the introduction of computer hardware, software. We look at computer networks, all the way to computer operating systems. The second topic will be introduction to computer applications. Those are the application softwares. We look at word processing all the way to PowerPoint. Then we look at use of computer in research. How do you use ICTs in research and in data management? Then another major topic would be the role of ICT in professional practice. How do we use ICT to improve efficiency and effectiveness? What is the role of ICT in health and telemedicine? Because AMREF International University, we offer courses which are health related, and the students are having or taking health related disciplines. So we are going to focus on the ICTs which are being applied in the health sector. So the role of ICT in health and telemedicine. Then we look at the challenges facing application of ICT, then the influence of ICT on work ethics and productivity and delivery of services. We look at the challenges in the adoption of ICT, that is the investment, the security, sustainability, compliance. And the last topic we are going to look at is the computer ethics, because it is good to realize that, and it's also part of the challenge, computer ethics. It has brought in so many, we call it, it's a double-sided sword. It has positive and negative impacts. So we are going to look at computer ethics. What are the etiquettes? How do we behave when it comes to using ICTs, the ethical use of ICTs, and how do we safely handle ICTs? So that is what we are going to cover as the content, and I believe by the end of covering this content, we will have managed to answer or to achieve the 4 objectives. In terms of the mode of delivery, I don't want to discuss this because this course outline is a general one. It was meant that made that when we were doing face-to-face. However, due to what is prevailing now, we are going to have online lectures. We are going to have online group discussions. We are going to have online research, and we are going to have online practical assignments and online assignments, basically. So that is how I'm going to deliver this course. And in terms of the assessment, how I'm going to assess you, we are going to have 2 continuous assessment tests, which will contribute to 30%. It might be 15-15, or it can be 20-10, depending on what I will decide to test you on. Then at the end of the trimester, come December, we are going to have the end of trimester examination, which will contribute to 70% of your final mark. In terms of the reading materials, these are meant for face-to-face if you are doing it physically here in AMREF. But because of what is happening, that is the online teaching, after every topic, the last slide will be the reading materials, which will be purely online, such that you don't need to necessarily come to the university physically to get the learning resources or the reading materials. So I will send you a link which you can read online. You can download the book or even the article, even the presentation, and you read for further maybe information. So that is how I intend to offer the course, and that is basically what the course outline covers. So at this time, before I move on, I want to welcome any comment about the course outline. If there is any. Okay, there being no comment, I want now to straight away move to our first topic. And Let me share my first so I believe you can see my slides.
Yes, we can.
Yes.
Yes, we can.
Yes, we can.
So this is a university common course, and it is to be taken by all undergraduate students who are doing bachelor's. And the objective of this course is to enhance the knowledge, skills, and competencies in the ICT world. You know that we are in the ICT world, and ICT is part and parcel of our lives today. And also to understand how ICT affects our daily lives and operations. The first topic we are going to look at is the history of personal computers. And it is important to study the history of computers for two major reasons. First is to understand the evolution of technology. Technology has evolved over time. So we want to understand where did it start and where is it now. Secondly is to appreciate and acknowledge the people behind this involvement. The evolution of technology has not happened on its own. There are people behind it. There are people who are pushing or even are involved in this evolvement of technology. So we want to know who are these people so that we can appreciate and acknowledge their contribution to the evolution of technology. That is the major reasons why we are going to study the history of personal computers. So these are the topics we are going to cover in our first topic, that is the definition of computer. We are going to look at the earliest forms of computers. We look at the milestones or the timelines in terms of computer history, and then we group these forms of computer into generations. So that is what we are going to look at as the subtopics in terms of the topic history of computers. The objective of this particular topic is that by the end of it, you should be able to develop a familiarity with the history of the personal computer, describe the earliest forms of computer, highlight the major milestones in the development of modern day computers and the internet, and we list some names of persons responsible for development of computer and related technologies. So we start with the definition of a computer, and I say that a computer is a programmable machine. And what I mean by programmable is something which can be instructed on what to do. When you instruct, maybe like when you set an alarm to wake up at 5 a.m., we can say you have programmed your alarm or your clock because you have instructed it on what to do. So we say a computer is a programmable machine because it has to be instructed on what to do. It cannot do what it thinks or it feels like doing. It has to follow instructions which are defined by human beings. So we say one, it is a programmable machine. Another definition is that a computer is a machine that manipulates data according to a list of instructions. What we mean by manipulated data is to change data, to control, to use, or even to handle data. But in controlling, in changing, in using this data, it has to do this following a set of instructions. And this set of instructions are issued by human beings. So it manipulates data following those set of instructions. Another definition I can give for a computer is any device that aids humans in performing various kinds of computations or calculations. So any device that helps people to compute, any device that helps people to calculate, we can term it as a computer. So the question you might ask is, a calculator helps us to calculate. Does it qualify to be a computer? We are going to see that later. So when we define a computer, three principal characteristics come out. And one of the characteristics is that a computer responds to a specific set of instructions which are well defined. So it does not work without instructions. And these instructions are well defined. And as I said, when I was talking about being programmable, follow your set of instructions. All these instructions are structured, and they are structured and set by human beings. So that is a principal characteristic coming out from the definition of a computer. The second characteristic is that it executes, or it implements or effects these list of instructions which are already defined. They are already pre-recorded. So it means the list of instructions come first, and then the computer is to read those list of instructions and then implement. So it implements an already defined instructions. And thirdly is that it can quickly store and retrieve large amounts of data. So a computer has that characteristic of being able to store and even to retrieve large amounts of data. So those are three principal characteristics of computer which are emanating from the definitions we have given. I move on to look at the earliest computers, and I started by saying that originally calculations were computed by humans whose job title was computers. So the way I've said that computers is any device that helps human beings to calculate. So when calculations were being computed by human beings, those human beings or those staff who are involved in calculations, their job title was computers. The same way you are working in an hospital, you can be maybe a nurse, a nursing assistant, whatever kind of job title you have at your place of work, or whatever job title you are eyeing to have when you get employment, or even when you self-employ yourself, because you might be the director. Then that is what I'm calling the people who were involved in calculations, who were doing computations. Those early days, their job title was computers. So these human beings, so we can call them human computers, were typically engaged in the calculation of a mathematical expression. So they were basically involved in calculating, in performing mathematical expressions. And for you to qualify to be a human computer, it required you to undergo a period of specialized training. This specialized training was in mathematics, and majorly it required you to spend several years being trained on calculations and mathematics. So the first use of the word computer was recorded in terms of literature in the year 1613. You might think it is a new term, but it's a term which has existed over time, over centuries, many centuries ago. And you can see that the first time it was used, it was in the year 1613. And it was used to refer to a person who carried out calculations and computations, as I've explained. So the first computers were basically people. So when we look at the earliest forms of computer, we can say the first computer was a human being. Because, and not any human being, but those human beings who were involved in computations or calculations. This was a job title given to people who did repetitive calculations. But that was just the term computers. There is another term here which is called the personal computer. And the term personal computer was introduced in the lexicon or as a terminology in the year 1975. And what it meant is that computers were developed to be made accessible to individuals. As we are going to see, as we go along with the history of computers, you realize that computers initially, or the early forms of computers, were majorly for government operations and for big companies or businesses. There were no computers for individuals. So somebody like yourself or myself could not afford or even access to buy a computer. But from the year 1975, computers now became, it became possible for people, individuals to buy and to access computers. And therefore, computers ceased to be just computers, and therefore that term came in, personal computers, meaning it can be owned by an individual. And that's the reason the next bullet says, up to that time, computers had been very large and expensive, and they were majorly operated by big companies. So before 1975, they were very big, they were very expensive, and therefore it was a preserve for big companies and governments, meaning that people could not access. But from 1975, now it was possible for people to access computers and purchase for their own use. So we have said that the first form of computer was a human being, but we can trace other forms, earliest forms of computers, and I start with what we call the tally sticks. The tally sticks, as we know, they actually in calculations, addition, subtractions, and it's a memory aid device to record and document numbers, quantities, and even messages. So because it aided or it helped in calculations, in documenting numbers, that translates to LP in computation, and therefore it can be termed to be a form of a computer. Another form of a computer is the abacus. And the abacus is a calculator, and it was first recorded. Its use was recorded in the 500 BC, and it's a Chinese invention. And it was being used for addition, subtraction, division, and multiplication. So you can see abacus was helping people to calculate. So if it is to calculate and to compute, and from what we have defined in our introduction in terms of what is a computer, that device which helps in computation, then the abacus also qualifies to be termed as the earliest form of a computer. Another early form of a computer I can say is the analytical engine, and this was the first mechanical computer. And when I talk about a mechanical computer, as you know about mechanics is all about use of gears and all that. But the other forms like the tally sticks and the abacus, they were not using any gears. They were basically manual. And now analytical engine brought in it. We can say it was the first mechanical computer, and it was conceived and constructed partially by a gentleman called Charles Babbage in the years between 1822 and 1871. And this mechanical computer was designed to receive instructions from a punched card. So the way you can punch a paper and you have that hole which has been punched. That time this computer used that hole which has been punched on a card. It is the one which contained the pre-recorded instructions. If you remember how we defined how computers were receiving instructions. So that hole is the one which contained what instructions were to be done by this mechanical computer. And it actually made calculations with the aid of a memory bank and a printout solutions to maths problems. So you can see it was basically to do mathematical problems. Then another form of early computer is the slide rule. And the slide rule was invented by William in the year 1622. And it is based on Napier's about logarithms. You can see it's all about mathematics, mathematical expressions. And it was primarily used for multiplication, division, calculation of roots, logarithms, trigonometry, and many others. But one shortcoming with the slide rule is that it could not add or subtract. So it had that shortcoming. Then another form was the stepped recorder, which was invented by Godfrey in 1672, and also it was a machine which could do mathematical expressions like addition, subtraction, multiplication, and division. And now one thing with this machine was that the stepped recorder is that it could do this automatically. So the issue of automatic calculations came in. We had also another form of early computer called the Jacquard loom. And this was a mechanical loom which was invented by Jose Maria Jacquard, and he named it after himself in the year 1881. And it was an automatic loom controlled by punched cards. So the cards which were punched also contained the instructions. And when we talk about a loom, it's a I can say it's an equipment used in weaving industry or the cloth industry for designs, for fabrics and all that. So this helped a lot, being an automatic one, whereby the punched cards could contain instructions on what designs the fabric could have. Then that is what Jacquard loom was doing, being a mechanical loom. Then we had a arithmometer. This was a mechanical calculator invented by Thomas de Colmar in the year 1820. And it was the first reliable, useful, and commercially successful calculating machine. So this was a machine which was the first mass-produced calculating machine. Mass-produced meaning they were produced in numbers so it could be sold to businesses and to companies. Then we had the tabulating machine, which was invented by Hermann in the year 1890. And this was a machine which was assisting in summarizing information and accounting. And it was later used, that year it was used to help the census county for in the US in the 1890. Hermann worked with the US Census Bureau and Statistics. And the year 1880, they carried out, they conducted their national census. And when they conducted their national census, it took another 10 years for the results or the statistics of the census to be out, because they are doing the calculations, the computations of the statistics manually. So Hermann thought that that challenge needed to be solved. And as we saying that necessity is the mother of invention. So that problem of counting or calculating statistics for 10 years until another census is here prompted Hermann to think of a way to invent this tabulating machine so that it can help them in the next census. And we are going to see how actually it helped them in the 1890 census. So brief timelines in terms of the history of computers. We start with the 1801, between those years of 1800s and 1801. That is where we have seen in France, Joseph Marie Jacquard invents a loom that used punched wooden cards to automatically weave fabric designs. And as we have seen, most of the early computers used similar punch cards. And these punch cards were not paper punched, but it was wooden, and you punch the wood. And as I've said, the hole is the one which contained the instructions. 1822, an English mathematician called Charles Babbage conceived the steam-driven calculating machine that would be able to compute tables of numbers. 1890, Amman designed a punch card system to calculate the 1890 census, as I've said. And with that, what we are calling the tabulating machine, it helped in accomplishing the task of 1890 census into just 3 years. Remember, from 10 years to 3 years. And that saved the government of the US $5 million. This gentleman called Hamann later on is the one who eventually established the company we know as of today as IBM. You know, IBM is one of the key, one of the main brands in the computer industry. So its genesis is that it was established by Amman. 1936, Alan Turing presented a notion of a universal machine, which later on it was called the Turing machine. And this was a machine which was capable of computing anything that is computable. As we have seen from the history we have looked at, is that computers were basically doing computations or calculations of addition, subtraction, division, logarithms, roots, trigonometry, and all that. Only that. But there is a lot which can be computed. So 1936, Alan brought in this machine he named it after himself, Turing machine, which now was able to compute anything which could be computed. And that is where the idea of a computer, even the computer of today we know, or ICT tools we know today, which can almost do anything, started. So it started from this, the idea started from this gentleman when he presented this universal machine which could compute anything. So, and that is the central concept of the modern computer, whereby it can compute anything. 1937, Atanasov, a professor of physics and mathematics at Iowa State University, he attempted to build the first computer without gears, cams, and belts or shafts. I said previously we have seen that computers were, some of the computers, early forms of computers were mechanical. That meant they were using gears and all that. So this time now, 1937, Atanasov now started thinking of or attempted to build the first computer with a computer not being mechanical. 1939, Hewlett Packard was founded by David Packard and Bill Hewlett in Palo Alto, California, in a garage. And you know that Hewlett Packard is basically the HP, the brand of computers we know of today. You know there are various brands of computers. So one of them is HP, and you have seen it. It's one of the most preferred brands in the market. So it traces its history to 1939 to these two gentlemen, David and Bill, and they actually named it after their surnames, Packard and Hewlett. 1941, the professor Atanasov we had talked about, who started now attempting. Remember, 1937 we have seen he started attempting. So in 1941, together with his graduate students, student who is Clifford Berry. So he was supervising this student who was a physics, a PhD student taking physics in that university. So they designed a computer which could solve 29 equations simultaneously. Previously, computers could only solve one problem at a time. So if you add this, you cannot give another instruction until one instruction is over. So you have to wait for one instruction to end or one mathematical calculation to end for you to issue another one. So it is during this time now, Atanasoff and his student Clifford now brought in the idea of a computer being able to solve up to 29 equations simultaneously or at the same time. And this is the time which marked, this is the first time which marked a computer to be able to store information on its memory. Remember, for these instructions or these equations to be solved simultaneously or at the same time, they need to be stored somewhere in the memory of the computer. So for them to be stored, now the computer needed to have a memory. And therefore, this is the 1941 ushered in the issue of computers being able to store information and computers being able to have memory. 1943 to 44.
Excuse me, Miss Penina.
Yes.
May you please zoom into your slides? They're a little bit smaller. I can't see.
Okay, I'll do that. Sorry, thank you.
Okay, thank you.
Is that okay?
Yes.
Perfect. So I was in 1943 to 1944. Two university professors of the University of Pennsylvania, John Mackley and Presper Heckard, they built electronic numerical integrator and calculator, what it was called ENIAC. When you look at most of the literature, they talk about the first computer being ENIAC, and maybe you might have heard this from various sources that the first computer was called ENIAC. But there was a lot happening before even ENIAC was built. So actually ENIAC came in during these years, 1943 and 44. But as you have seen, there were other forms of early computers which we have seen, but people know ENIAC to be the first computer. But what we can say that ENIAC can be considered to be the grandfather of digital computers. What we have seen previously were mechanical computers, but now ENIAC ushered in the era of a computer being digital, a computer not being analog, but being a digital computer. This computer, which is ENIAC, it was very huge. It could fill a 20-foot by 40-foot room, and it had over 18,000 vacuum tubes. And you remember when we were defining computer, we said they were very huge. And one of the reasons, you see, they were very huge to fit in this kind of a room, 20 by 40-foot room. So they were very big. And 1946, the same professors left the University of Pennsylvania, and they got a funding from Census Bureau in the US to build the second version of ENIAC, and they called it the UNIVAC. And we can say that this was the first commercial computer for business and government publications, not publication, but applications. So this was a computer which could now be sold. It was commercial, and therefore businesses, governments could buy this UNIVAC and they use it in their business environments or in the government offices. 1953, Grace Hopper developed the first computer language. So the first computer language was COBOL. And we trace this to a lady. So, and remember, when you're looking at the timelines, we are not necessarily looking just at the hardware. We also look at the related technologies and software. So one of them is the computer language, and we say that the first computer language was COBOL, and it can be traced to the years 1953 to a lady called Grace Hopper. 1954, the first programming language was Fortran. It was developed, and it's actually Fortran means formula translation, and it was developed by a team of programmers who were working at IBM. 1964, Douglas showed a prototype of the modern computer with a mouse and a graphical user interface. So previously, computers did not have peripherals like mouse, like a keyboard, and all that. So the way of navigation was very tricky. But now, 1964, Douglas brought in a prototype, and a prototype is a model of how the modern computer would look like when it has a mouse and it has a graphical user interface, which helps now people to navigate. And with this model, it marked the evolution of the computer from being a specialized machine for scientists and mathematicians only to technology that is more accessible to the general public. Remember, we said that computers were previously meant only for calculations, for computations, and all that. So it meant they were only being used by scientists and mathematicians. And they were being trained, the specialized training we were talking about, on how to use the computer the way it was. So when Douglas brought in this model of a modern computer having a mouse and having a user interface which you can navigate and interact with, it opened now avenues for computers to be used by the general public to navigate, because using a mouse and having the computer being able to having the computer with the user, with icons, menus, and all that, it's possible for any person, for the general public, to interact with it. And so 1964, now people could now access or people who are non-scientists and non-mathematicians could now use the technology. 1969, a group of developers at Bell Labs produced Unix. And Unix was the first operating system, and actually it addressed what we call compatibility issues. Computers before that came with their own operating system. So the manufacturer of a computer had to install or also to develop the operating system. So you buy a computer together with the operating system. But now, 1969, these developers produced a standalone operating system which was called Unix, meaning that you could buy the hardware or the shell, let me call it the shell, then you buy an operating system and then you use it on your computer. So the issue of compatibility was addressed by this group of developers when they came up with Unix. 1971, Alan led a team of IBM engineers to invent what used to be called floppy disks. Floppy disks allowed data to be shared among computers. So it means before 1971, data was stored on the main memory of the computer and it could not be moved or it could not be shared with another machine because there was no device to help in sharing. But now Alan, with these other engineers, in this year 1971, they developed or they invented the floppy disk, and that allowed data to be shared among computers. So you could move or share, get data, move data from one computer to another computer using a floppy disk. 1973, Robert Metcalfe developed the Ethernet. Now we are coming home to see where we are with technology today. So Robert is the one who developed Ethernet. That is the connection of networks, and that allowed connecting computers and other hardware. So with the use of Ethernet, you could connect one computer to another, and they communicate or they exchange data. You could connect one computer to a printer, and therefore you could send data from the computer to the printer because of the use of Ethernet. 1974 to 77. Now, a number of personal computers hit the market. And you can remember where we said the introduction of use of the term personal computers came in the year 75. So this is the range, 1974 to 74 to 77 is now where personal computers now came into the market. And there were various forms of them, Shelby, Mac 8, Altair, IBM, and many others. So now computers started being sold in the market for people to own them. So the issue of personal computers came in at this time. 1975, two computer geeks, Paul Allen and Bill Gates, offered to write software for Altair. Altair now has come. We have seen in the previous bullet is that Altair was one of the brands brands of personal computers which was in the market. So Paul and Bill, now they offered to write software for that computer, and they were using basic language. And on April 4th, they succeeded on this first endeavor of writing the software for Altair, and they continued to be friends from their childhood, and they are the ones today we know they own the software company called Microsoft. People think Bill Gates was the founder and all that is termed to be to be the owner and all that. But if we look at historically, he started this with his childhood friend, the Paul Allen. So they are the ones who own that software company. 1976, Steve Jobs and Steve Wozniak started the Apple computers. You know, Apple computers is also a brand in the ICT world, and they rolled out their first version of Apple computer, that is the Apple I. 1983, Apple Lisa was the first personal computer with a graphical user interface, and it had features like drop-down menu and icons. Even though it did not go far, it flopped. But eventually it evolved to what we used to know, maybe some of you know, some computers which were called Macintosh. Actually, it was now the evolvement of Apple Lisa. 1985, Microsoft announced their first operating system. Remember previously the operating system we had was Unix. So the second operating system comes in on board and from Microsoft company, and that was Windows. Still in 1985, that is the first time the first .com domain name was registered. The way we say www.google.com. That is now when those are the idea of .com domain names started. That's when the first one was registered. 1990, Tim Lee developed the hypertext markup language, or what we call the HTML. And HTML is the one which gave rise to the ability or to have the World Wide Web or the internet. 1996, Brin and Larry Page developed the Google search engine. So the Google search engine came in 1996 by these two gentlemen, Brin and Larry Page. 1999, Wi-Fi, wireless, what we call the wireless hotspots. It became part of now the computing language, and now users began connecting to the internet without wires. So what we saw was Robert Metcalfe invented or brought in the idea of Ethernet. Ethernet is the cable which you use to connect to internet, to your computer. So that was what was working up to 1999, when now the idea or the term wireless or Wi-Fi came in, and these allowed the people to connect to the internet without necessarily using wires. 2007, the iPhone. iPhone was one of, it's an Apple product. And iPhone now brought computer functions into the smartphone world. So before this, computers were the ones which were doing computer work and all that. But since the year 2007, iPhone was the first mobile to have a smartphone which could act like a computer. And you know that even up to today, we use smartphones as computers. Some of you are logged in using a smartphone. Others are using a desktop computer. Others are using a tablet. Others are using a laptop. All those are forms of computer. So, but we are saying from the year 2007, now smartphones, starting with iPhone, was able to have computer functions in them. So that is the history of computers, the early forms, the milestones, and even the people behind those developments. So looking at those developments of all of what the early forms of computer are up to where we are, the smartphone technology, computer being able to work as a phone being able to work as a computer. We want to group these forms of computer into generations, and they can be grouped into 5 generations. First generation ranges from the year 1940 to 56, second 1956 to 63, third 1964 to 71, fourth 1971 to 2010, and fifth generation 2010 to today and to future, when we'll maybe the ICT gurus will decide now we are in the 16th generation. So we want to cover that. We look at each of those generations in detail. So starting with the first generation, the first computers used vacuum tubes. If you remember, like I said, the ENIAC, which was very huge, fitting into a 20 by 40 foot room and using over 18,000 vacuum tubes. So first computers were using vacuum tubes for circuitry. Circuitry is the transmission of power within the machine. How power will be transmitted across the machine. So those first computers were using vacuum tubes. As you can see them here, this is an image of a vacuum tube. So these are the tubes which were being used to transmit power within the various parts of the computer. The first computers were using magnetic drums for memory. And as we said, memory was for storing information or data. And because of that, because of using the vacuum tubes and the magnetic drum, these first computers in the first generation, they were very enormous. They were very huge. And that made that they took an entire room, like what I said. In addition, they were very expensive to operate, and they were using a great deal of electricity. So the electricity to power 18,000 vacuum tubes, these small, you can see these tubes, 18,000 of them in one computer. So it meant they were using a lot of electricity. And this meant they generated a lot of heat. So the issue of overheating and all that, there was a lot of eating wherever the computer was. And that overheating or generating a lot of heat caused malfunctions. So computers you would find that they were failing because of overheating. So they used to malfunction so frequently. Also, first generation computers relied on machine language, which was the lowest level programming language understood by computers only. So first computers did not allow what we call the human language. So they used purely to understand and to work with machine language. And this was the lowest level of programming language. So they used that to perform operations, and they could only perform or solve one problem at a time. Input into the computer was based on punched cards and paper tape. So, and this one I explained. Input is now transferring what the human being wants the computer to do. What instruction you want the computer to do, that is now what we say as input. You want to input the instruction to the computer. So for you to input the instructions, there was the use of punched cards and paper tapes. And now for the computer to output or to give you the response, in case it was a computation, you instructed to do a computation, so you want to see the answer. That is the output. It was displayed on printouts. So it was not being displayed on the screen. You see, like today, if you are typing, you input through a keyboard. That is, you are sending the instruction that type this. Then the computer outputs to you through a screen. That is, you are able to see what you are typing. If it's calculation, you calculate 1 + 2 + 2, you enter through a keyboard. Then the computer you are able to see through the screen that this is the answer. But now that time, the output came out in form of a printout. So there was no the use of screens. And two notable machines of the first generation was the UNIVAC and the ENIAC machines. Now moving on to the second generation of computers. Now, in the second generation of computers, transistors, this is an image of a transistor, replaced the vacuum tubes. So, for circuitry or power transmission within the computer, now second generation computers were using transistors. And it is said that one transistor replaced an equivalent of 40 vacuum tubes. So remember, like the 18,000 vacuum tubes divided by 40, you get the number of transistors now, which now are being used in the second generation. And because of that, these allowed computers to become a bit smaller. It also allowed computers to be faster, cheaper, and also more energy efficient and more reliable. However, still, they generated a great deal of heat, and also that led to damaging the computer malfunctioning because of overheating. Second generation computers moved from cryptic binary machine language, which was what we said was the lowest level of programming language, to symbolic assembly languages, which now allowed programmers to specify instructions in words. Now, initially, now the machine language was in terms of binary digits, 1, 0, and all that. And those instructions the computer could understand, but as a human being, you could not understand. But now the era of second generation, programmers now could issue instructions in words which human beings could understand. Still, the second generation computers relied on punched cards for input, and printouts was also the output. So these are common characteristic or feature of both first and second generation. Now, in terms of memory, we said that the first computers were using magnetic drums for storage of their instructions. Second generation instructions were stored in magnetic core technology. So we can see a development there in terms of memory. Moving on to the third generation, Moving on to the third generation, I wanted to mute the person who is not muted. Moving on to the third generation of computers, and in the third generation, there was the development of integrated circuit, and these are an image of what we call the integrated circuit, and also that now replaced the transistors. Transistors were miniaturized, which were placed on silicons or called semiconductors. So this, what we are calling integrated circuits, they were a form of transistors, but transistors which were mini or small in size, and they were pasted or placed on silicon chips, which were called semiconductors. And the use of integrated circuits increased the speed and the efficiency of computers, and also it made computers much smaller and cheaper compared to the second generation of computers. And also, because of that, you can see we have said it increased the speed and efficiency. So computers could carry out instructions in billions, many instructions within a second, billions of instructions within a second. So the speed was increased. Still in the third generation, users who interacted with that generation computers through keyboards. So this is the time now keyboards came on board in the third generation computers. Monitors, now you could have a screen to see the output instead of having the output through a printout. So keyboard was used for input, and they were interfaced with an operating system which allowed the device to run many different applications at one time with a central program that was monitored through the memory. So you could have many applications in one computer. So you have a word processing, you have an Excel, you have a web browsers, you have many applications. You even install systems at your workplace, like an hospital management system, maybe an ERP, that is the electronic resource planning system. So having many different applications within the same machine. And this is the time now computers for the first time became accessible to a mass audience or to the public, because now they were much smaller and they were cheaper than their predecessors, than their first and second generation of computers. The fourth generation of computers, microprocessor came in. And this is now which replaced the integrated circuits. And we say that one microprocessor replaced thousands of integrated circuits. And what happened is that thousands of integrated circuits were built onto a single silicon chip. So if you look at what we have discussed between the second and the third, transistors, many transistors were built on a silicon chip, and that became an integrated circuit. Now moving on to the fourth generation, many integrated circuits were built onto a silicon chip to make what we call a microprocessor. So you see there were inventions. People were looking at how to improve the circuitry, how to improve the memory, and many things. And these computers became more powerful, and they could be linked together to form networks, which eventually led to the development of the internet. Now, with the use of microprocessors, it was possible to link or to connect one computer to the other. And when we say that internet is actually connection of many computers, two or more computers, you make an internet for them to communicate. So you can see this came in the fourth generation. Also in the fourth generation, computers, they saw the development of the graphical user interface. Computers coming on with drop-down menus, with icons, which you can relate with, which you can see, you can click and all that. And then the use of the mouse and the use of handheld devices to navigate across the menus and the drop-down icons. To the last generation of computers, that is the 5th generation, and now this was based on what we call artificial intelligence. Artificial intelligence means that computers could have the intellect of a human being. And we said, when we were looking at the years of these generations, we said the 5th generation is where we are today. And I bet you know that the computer of today, the ICT tools of today, somehow they have the intellect of a human being. I'll give an example. You start typing, or you want to do a search, and maybe you misspell a word. It asks you, did you mean this? That shows that computer or whatever technology it has, it's in a position to think, like to have the intellect of what you want to mean. It can fill in what you mean. Look at our phones, because even our phones, as we said, they are computers. When you start maybe calling and all that, it can give you an history of whom you have called and all that. That it shows it is trying to have the intellect of a human being, because of course a human being, like I can remember that whom I talked to since morning, I talked to A, B, C, D. So that is what the phone is trying to tell you, that since morning you called so and so and so that and so and so. So are they what we call an artificial intelligence? Look at another example is how some devices, like you use your face, you use your fingerprint to open a particular device, like your phone. You are entering your office, it has a smart lock, you use your fingerprint, or even you use your face. What that means, the technology, which is ICT, being used, it has that intellect to think like a human being. So that is the technology we are in today. And we are saying that 5th generation computers, they are still in development. We are seeing them, but they are still in development. And that's the reason I've said we are not yet into the 6th generation, because 5th generation computers are still in development. What is making the 5th generation computers to have the artificial intelligence is what we call the use of parallel processing and the use of superconductors. Those are the main two things which are making 5th generation computers to have artificial intelligence as a reality. And another goal is that for 5th generation is to have devices that respond to natural language input. For instance, you know that you can, if you are searching from a computer, you can speak to it instead of typing. It depends with your English, how you pronounce. Do you have the mother tongue kind of interruption and all that? But you can speak to a computer and it types or it searches what you type. When we go to research, there are application softwares, like you go to the field, you collect data through an audio recording, and you come and plug in the audio recorder into your ICT tool, and that recording is transformed or transcribed into text, word by word. So that is what we are calling that device is able to respond to natural language. When we talk about natural language, is the way we speak, the way I'm speaking. A computer can understand what I'm saying. A computer can even transcribe what I'm saying. And in the fifth generation is where we're having some applications such as voice recognition. And I believe you know that, like, even Safaricom today is using sauti yako, sijui sauti yako something. That is the application of voice recognition. And that is in the fifth generation. So you find that in the fifth generation computers, they are trying to think, to act like human beings. And that's the reason we have said they are based on artificial intelligence. And that is the generation of computers, which is still ongoing. So that marks the end of our first topic. And I hereby list 5 resources, which you can see they are hyperlinked. Some are YouTube, so you can listen. Others are textual, you can read, and many others. So 5 of them. So what you need to do is you just, once you get the PowerPoint slides, you click on the link and it takes you, or it opens that resource or additional reading material, which you can read further to build up on what I have shared with you in class today. So that marks the end of our first topic and also marks the end of our lecture today. So I welcome any questions because I can't see any question from the chat. Yes, I can see there is one. Oh, no, it was, I don't know what she meant. Esperanza says yes, I don't know what she meant with that. Oh, she meant when I was asking whether you are hearing. Thank you, thank you. So I can't see any question or comment on the chat. So I give this opportunity for anyone to raise any comment, to raise any question. So this is your time. Yes, Nicole Combe.
Hello.
Hi, Nicole.
Yes, Nicole.
Hi. I have a question. It's not really about the class in particular, but I was
Yes.
hoping that you would help me answer.
Okay.
I'm enrolled in the health systems management and development course, but I
Yes.
was wondering, because it's part-time, if I can move to the community health and how I would go about that.
Yes, to respond to you, to respond to that, it is very possible. It is very possible to change our course. And I want to advise you, if you want to change our course, please do it by the end of this week.
Okay.
And the process is,
Yes.
yes, I'm saying it's possible to change our course because, and it is important to do it as early as possible so that you are not left behind by the other students. As I said, these are common courses, so all the students are here, but you'll find the students who are doing community health, they have their own courses, which they might have started, I don't know. So what I advise you is, I'm going to share, since I have your email address, I'm going to share with you the phone number and the email address of the HOD for community health practice so that you express your interest to change the course, and he will guide you on what is required. Because one, we have to look at, do your qualifications allow you to join that course? If the qualifications will not allow you, it will not be possible. So you will be advised accordingly. So once I end this class, I'll send to your email the email address and the phone number for the HOD to guide you accordingly.
Thank you. Thank you.
Sorry, sorry, members. I dropped off. I dropped off because I think there was a connection issue. Nicole, I hope you got my response.
Yes, I did. Thank you.
Oh, welcome. So I go to I can see Gikoroki, you have raised up your hand, please. I think Gikoroki is not available to tell us what is what is his issue or our issue. I don't know whether it's a gentleman or a lady. So Esperanza.
Yes, I was asking about the links.
The links.
Yes, how can we access them?
Yes, I've responded by saying that I don't know whether it has come through. No, it failed. I'll be sending the links of the recording. So through the same platform. And also I'm in mostly the WhatsApp groups of the various classes. So I'll also be sharing the links on the WhatsApp groups once I upload on YouTube. So it is a process. First, I'll have to upload on YouTube, then I share the link with you in various platforms through WhatsApp and through your email addresses. Another question? Okay.
I have a question.
Yes, who is this?
This is Elizabeth.
Yes, Elizabeth.
I wanted to find out.
Yes.
Just for planning purposes,
Yes.
how many classes are we going to have? Are we going to have 10 classes, 12? I mean, how many?
Elizabeth, sorry, I'm not in a position to answer that question because what do I say? This is defined by the head of department. You are in community health practice, right?
Yes, yes.
So the head of department of community health, who is Dr. Josephat Nyagero, should guide you on on how many courses you should take. But I know they should not exceed 7.
Oh, no, sorry. I guess you didn't understand what I meant by how many classes. I meant how many sessions. How many sessions are we going to have in terms of information, communication, and technology? This unit,
Okay.
this particular unit.
Okay, I get you now. Yes, we are meant to have 12 sessions. That is, every week we are supposed to have a session. And in case we don't have, the lecturer, who is myself, of course, is supposed to give some work. So you might find there's a week I've given you a case study to analyze and you discuss. So we are supposed to have 12 sessions, 12 weeks of teaching.
Thank you. Thank you. Thank you so much.
Welcome. Another question?
Another one. Sorry, I think I have many things to ask. I remember last semester we never went through the orientation on how to get into the library.
Yes.
The AMU library. May I kindly request if you'd spare some time so that you can take us through that?
Yes, you might have been disadvantaged. What I'll do, this intake of September, I did online, live. I can say a live orientation. So what I can do, I can also share the recording of the orientation for reference purposes.
Thank you so much.
Welcome. Anybody else with a question? I think without another question, I want to say that marks the end of our session today. I wish you a good night and be blessed and stay safe and healthy. Bye-bye.
Thank you so much. Good night.
Thank you. Bye.
Thank you.